again. We're going to do a brief review of Chapter 4, Carbon and Molecular Diversity. Hopefully by now you have already looked at the notes and have studied the notes. Now, from Chapter 4, I define organic chemistry. This is the study of carbon-based compounds, carbon-based molecules. An organic molecule is one that's made of carbon skeletons, that is a framework of carbon atoms. That was Roman numeral 1. Roman numeral 2 is basically why carbon? Why not something else? Well, carbon basically has a valence of 4, meaning that carbon tends to form 4 covalent bonds with its neighbors. Now, most other atoms may form less. So if you have a bunch of carbons, you can arrange them in a huge variety of ways. So this allows for the molecular complexity that life requires. In Roman numeral 3, we have variation of carbon skeletons. For that, you can refer to pages 60 and 61. A hydrocarbon is a molecule made of only hydrogen and carbon. The smallest is methane. The next one made of 2 carbons is ethane. Once you get up to 4 carbons, you'll notice you can arrange butane, isobutane. There are different ways to arrange it. Now, hydrocarbons aren't really the way organic molecules are in the body. So, we have to have functional groups. Now, I also define isomers in Roman numeral 3. Isomers are molecules that have the same number of atoms, carbons and hydrogens or whatever, but they're put together in a different structure. So, butane and isobutane are isomers. Now, Roman numeral 4, functional groups. A functional group is a group of atoms that are attached to a carbon skeleton that affect the properties of the molecule. Now, pages 64 and 65 of your textbook cover the functional groups, although the notes do not go over all of them, but follow what the notes cover. So the hydroxyl group is an OH. Hydroxyl groups are found in sugars and alcohols. So, for example, if we have the hydrocarbon methane and we were to replace one of the hydrogens with a hydroxyl group, we now have methanol. Methanol is a liquid. Methanol is polar. Methanol can mix with water. You can still burn it though. So functional groups do affect the properties of a molecule. The carbonyl group is a C double bond O. Now there's 2 types of carbonyl groups, and that's in your notes. Now carbonyl groups include aldehydes, in which case there's a hydrogen on one end and a carbon skeleton on the other, or ketones, in which the carbonyl group is kind of in the middle of the molecule and you've got carbons on both sides. So those are carbonyls, aldehydes and ketones. Under C we have the carboxyl group. C double bond O, OH. This is an acidic group. It's used in the carboxylic acids. D is the amino group. The amino group has a hydrogen and 2 oxygens. The amines, such as amino acids, have an amino group. These drawings are in your notes if you can't see this very well on the screen. The sulfhydryl group is a sulfur and a hydrogen attached to a carbon skeleton. Organic sulfides have sulfhydryl groups. The phosphate group is basically a phosphorus and 4 oxygens attached to an organic molecule. And phosphates, organic phosphates, are very common in biology. So those are the functional groups, and that pretty much concludes the review of Chapter 4.